Hello and welcome to today's session. Today, my name is Rizwan Razaq, and I'm the CTO for Middle East and Africa region. Today's session, I will be talking about Huawei inverter string design and specifically how to optimize in the inverter string design configuration with the PV projects. So without any further delay, thank you all for listening, and we will go into the agenda of today's session. So there will be several different topics that will be discussed today. One, which I'll start with, of how to design a PV string. Secondly, looking at what is DC to AC ratio, inverter string design, high DC to AC ratio using Y connectors, and then lastly, looking at high DC AC ratio with long string with optimizers. So all of these topics will be covered in today's session. And if you do have any questions, then please feel free to add them into the chat box, and we'll be happy to get back to you very soon with any responses that are available from Huawei. So the first question that normally gets asked, and which is able to be adapted with the how many modules can I connect into one string? So Huawei, first of all, before going into any technical aspects, Huawei has an online design tool, and that online design tool is available on our Huawei Solar website. And you can click the link directly on there to access that web-based online portal to design your system efficiently and give you an estimated yield report for your project and recommendations on the PV modules that can be connected. That will be covered in another session, but today I will be looking at the string inverter design itself. So there is two standards that normally need to be followed: the IEC 62548 standard, which is normally based for the utility scale applications, and then there is the IEC 62738 standard, and both of which are specifying the number of PV modules that can be connected in series is calculated using a standard. So as I mentioned, there's two types of standards, and the correct one based on your project type need to be adapted to. There is specific parameters in terms of the inverter datasheet parameters, and secondly, the module datasheet parameters that need to be extracted to correctly evaluate how many modules in a string that can be calculated. So here are some of the information that is available from the module. And as you can see there, the open circuit voltage and the maximum power voltage of that particular string are shown clearly on the type of modules. So we're looking today at the mainstream crystalline silicon modules and their specifications. So once that information is extracted, here are some examples on the bottom side of the screen. Let's go into a 72 cell PV module. And specifically, you can see there the number of PV modules based on the temperature that is expected on site. So, for example, between 0 and minus 10 degrees, you are able to comfortably connect a 335 watt peak modules of 19 panels per string. So that is the recommendation, and that information has been based on the module information that is available, and also taking into consideration the temperature calculation itself. The next topic we will be looking into in a great bit of detail is what is a DC to AC ratio. It's a very common question I get asked on let's say a weekly basis. What is the comfortable DC to AC ratio that I can be using for my project? And specifically, this is a question that I normally rebound back to my customers. What is the DC to AC ratio that you're looking to achieve? So let's go into it in a bit more detail. So in terms of the inverter, we have specifically an example on the screen here. The module's nominal peak power at STC conditions. So that's a 280 watt peak modules at STC conditions. The inverter rated power is 100 kilowatts. The 100 KTL M1 that we're referring to here. So based on those particular modules and the inverter having a capability of connecting 20 strings into that particular inverter, the calculation from the previous couple of screens based on the lowest temperature, we've allowed for 24 pieces of modules per string. So that provides a very comfortable oversizing ratio of 1.34%. So what does that mean? That means that STC conditions, normally around 25 degrees, that this inverter would be oversized by around 134%. Now, as we all know, you're not going to have a steady 25 degrees temperature throughout the year. You will have low temperatures and you will have high temperatures. So in terms of the inverter, will derate dependingly on the temperature, whilst the module's cell temperature will also dependent based on the ambient temperature on site as well. So these factors will change, and the AC to DC ratio will be modified throughout the day and throughout the year itself. So just to go into in a bit more detail in aspect of DC to AC ratio, one of the other most popular markets for Huawei and many other inverter manufacturers is Europe. So you can see here some examples of oversizing ratio for other regions. So here for Germany, you can see a 1.1 to 1.3 oversizing ratio, and that can be extracted, for example, a 750 kilowatt system, where you would have 6 of the 100 KTL M1 inverters installed, and that would then provide you a DC capacity of around 750 kilowatts DC. Other regions I would like to just highlight here. You can see in Latin America, they are having a different AC to DC ratio, and you can see there with a 300 kilowatt AC system, where there is 5 of the 60 KTL inverters, there is an AC to DC ratio of 1.2 to 1.4. So there is different AC to DC ratios, and for example, in the kind of Southern Africa region of South Africa, for example, we would recommend between 1.2 to 1.3% oversizing ratio. Now that is depending on many limitations. Obviously, what is your grid exported capacity, and also based on the type of installation, type of modules that you're looking to install as well. So with Huawei inverters, you can see here that there is multiple different types of inverters and different types of oversizing ratios. So let's just pick one, for example. One of the most popular inverters in the Southern Africa region currently is the Sun 2060 KTL M0. And that particular inverter has 12 DC inputs. And with those 12 DC inputs, you are able to connect very comfortably an AC to DC ratio of around 1.16 to all the way up to 1.54 oversizing ratio. So that's quite comfortable from the perspective of the inverter itself, and that is adaptable to what is required on site. So the next factor we will be looking into in a bit more detail is the inverter string design. And when we look at inverter string design itself, we need to be looking at what is the most suitable type of string and the oversizing that can be comfortably achieved correctly for the inverter to perform at its maximum power. So here are 2 very clear examples and what to achieve a DC to AC ratio of around 1.3. And the maximum modules per string allowed is around 20 modules based on the information and the formula followed in the previous screens. So there's 2 options to get that oversizing ratio and also the maximum amount of modules per string. You've got solution 1, where it's got a 380 watt peak PV module, 20 pieces of modules per string, 17 strings out of the 20 capability on that particular inverter, which is the 100 KTL M1, and that provides you an AC to DC ratio of 1.292. So that's option 1. And the option 2, which is the 380 watt peak module, 17 pieces of modules per string out of the capacity from the previous formula of 20. and utilizing all of the 20 string inputs, and that would provide you once again an AC to DC ratio of 1.292. So both cases are suitable, but Huawei has a preference, and what we recommend is utilizing the 17 strings of the inverter rather than 20. So let's look at it from two perspectives. Having 20 strings, that will increase your capex because there will be more cable required to extract that power from the PV modules back to the inverter, and also increase your labor on site as well. And secondly, from the aspect of performance, having the 20 PV modules per string will allow you to have a more higher voltage input into the inverter, which will be within the MPPT range of the inverter and providing you the maximum amount of power output from that particular inverter itself. So that's why we've mentioned there the preferred solution is the 17 strings, not the 20 strings. So this is something that needs to be really looked into in a bit more detail to ensure that you are getting the maximum power. And this option is available on the Huawei design tool as a preferred solution. Coming into the next subject and the types of inverters in terms of getting the further increase in DC to AC ratio. As we mentioned previously, the optimizers are a very good option. So in terms of the different types of inverters, so let's start from the bottom of the screen, a 2 to 6 kTL single phase inverter. To achieve a higher DC to AC ratio, you can utilize by installing optimizers, and Huawei has its own optimizers, the 450 watt optimizer. Second product, which is the 3 to 10 kTL three phase. Once again, we class this as a residential type of product. And in terms of getting a higher oversizing ratio, you can use an optimizer with that particular product. And lastly, the 12, 15, 17, and 20 kTL inverters are also adaptable to the optimizers as well. Now, in terms of the larger inverter, the 100 kTL M1, that particular inverter is able to have a very high AC to DC ratio, and that's using the Y branch connector. So I'll go through that in a bit more detail in the next few slides in terms of how to oversize your system with the Y connector itself. So the next topic follows on through to the DC to AC ratio with the Y connector and how to fully use that correctly. So specifically in terms of Huawei, we have a Y connector as an optional accessory, and this product will be purchased additionally from our partners. And once you purchase that connector, you are able to increase the number of inputs on the inverter. So as I mentioned previously, the 100 kTL M1 has 20 DC inputs, and you are able to use Y connectors onto the inverter to increase their number of inputs. Now, these Y connectors, I just need to mention, they do have a fuse protection inside of them because you're going more than 2 strings in parallel per each MPPT in order to be a safe application and be in accordance to the standards. We will need to ensure a fuse protector is incorporated within that particular MPPT. So these are the specifications. It can be purchased from Huawei or one of our partners, or alternatively, you can find a local supplier for these Y connectors. But I just would like to follow on in terms of the application and installation of the wiring. You need to ensure that the fuses are installed across the MPPT itself. So what I mean by that is the inverter input, for example, on each MPPT has 2 DC inputs. So you are trying to increase that. You are then going to able to connect 3 strings. So there will be a Y connector utilized for the single input, and the third input onto that inverter will also require fuse protection because that is a bus bar internally, and that could affect the inverter in terms of damaging the inverter if that inline fuse isn't incorporated within that MPPT. In terms of selecting the correct fuse rating, we need to refer back to the module datasheet. So here is just an example of extracting that. So on the left-hand side, you can see that the maximum series fuse rating is 15 amperes. And on the right-hand side, the maximum series fuse rating is 20 amperes. So this information needs to be selected from your PV module datasheet, and then the correct fuse rating can be incorporated inside of the Y connector, if that was to be a choice. The next topic will be looking into the high DC to AC ratio, and specifically the long string with optimizer solution. So here you can see an example of a residential application. A long string design with optimizers was incorporated. And what is a long string design? So with a power optimizer, the number of modules connected in a single string is more than the traditional string without optimizer. Why is there a long string needed? So the reason for that is enabling a more aggressive DC to AC ratio due to several different factors. Maybe a limitation of the power consumption on the premises, and secondly, due to the multiple different orientations that you are looking to install on your system. So you can see here from the image, there is an installation on one orientation and the main PV modules installed on the secondary orientation. So due to the different orientations, to utilize the maximum amount of power on the roof itself, you are then connecting all of that into a single string input. So the comparison between a normal and a long string design. So we need to look at one factor, which is the inverter input limit. So the max number of PV modules, based on the equation that we looked at in the initial couple of slides of this presentation today, there is a limitation of the number of modules per string that you can connect. So the module datasheet will provide you a specific voltage DC, and based on that calculation, that will then, based on the temperature and based on that the parameter of the module datasheet, that will provide you a recommendation of the number of modules that you can be connecting per string. So that will fix you to a certain DC to AC ratio. Now, in order to maximize or increase that string input, what you can do is, due to installing the optimizers on the application itself, you are able to bring the string voltage lower, and in effect, you are able to connect more strings in a series into a particular inverter. So as you can see, without the optimizers, 19 modules per string is able to be adopted. Whilst with the optimizers applied onto the project, you are able to achieve 30 modules per string. So here is two different examples, a case study of a long string design for a higher DC to AC ratio. So on the left-hand side, a 10 kTL inverter without optimizers, the max DC to AC ratio in terms of oversizing was around 1.25. So you've got two different strings, and on those two different strings, you can connect on, with the 10 kTL, you have two independent MPPTs. So one will be connected on string 1 and the second would be connected on the second string. Now on the right-hand side, what you are able to achieve with a 10 kTL inverter, a DC to AC ratio of a longer string design with the optimizers, you are able to connect in cases of 26 or even 27 modules per string. So that can utilize more power from the roof itself, and in effect, you are able to generate more power throughout the day with the capacity increasing in terms of DC to AC ratio. And if you wanted to, you can look at increasing this to a maximum capacity of around 200% if you were to do so. Right, today I would like to just say thank you very much all for listening. I hope you found it informative, and if you do have any further questions, please feel free to add it into the chat box, and we'll be happy to get those answered and contact you back with those answers as well. Thank you very much and have a good afternoon. Bye-bye.